Okay, today's topic is about preparation of benzene. The structure of benzene was for many years a problem for chemists. Molecular formula C6H6 was established in 1834, but no sufficient model of the structure was provided until many years later. Okay, for this part, actually they knew the empirical formula. You know, in an empirical formula, you know the types of the elements. Carbon was there, hydrogen was there, and later on, and they knew the ratio. For each carbon you have one hydrogen, for each hydrogen you have one carbon, 1-to-1 ratio. And later on they found the molecular formula. There was 6 C6H6, 6 carbon atoms and 6 hydrogen atoms. But they couldn't figure out the structure of the benzene. Okay, so Kekule, a German chemist, okay, he has discovered the structure of the benzene. He said he had discovered the ring shape of the benzene molecule after having a reverie, it's kind of daydream. Okay, in his daydream, he has seen a snake seizing its own tail. Okay, it's kind of cyclic. Okay, you guys, a snake was seizing its own tail. Okay, and he had the vision of the structure. This vision came to him, of course, after years of studying the nature of carbon-carbon bonds. Okay, actually was 7 years after he had solved the problem of how carbon atoms could bond to up to 4 other atoms at the same time. Okay, that's kind of, you can learn a lesson from this. Okay, if you have a problem, just don't give up, don't be hopeless. Okay, just put your effort, and then this kind of intuition. Okay, like you study hard for many years, but the solution, it appears suddenly. Okay, it's kind of intuition. It happens to Mendeleev too. Okay, when he was building his own periodic table. Okay, oh, that's it. And you can prepare benzene from hexane, sodium benzoate, and acetylene. Okay, here you have you have hexane. Okay, if you remove hydrogen from hexane, you can obtain benzene. And then you have acetylene. Okay, ethine. Okay, from ethine you can get benzene. Okay, the sodium benzoate part is not here, but I'm going to explain one by one. Right, like the first one is from normal hexane. Okay, so it is kind of N-hexane, 6 carbon atoms. You know, it is going to be C6H14 alkane. Okay, so if you remove a hydrogen from this, you get benzene C6H6. Okay, 8 hydrogen, I say 4 hydrogen molecules. You have a hydrogen atoms there. Of course, you need pressure, you need temperature. Here it is written 500 degrees Celsius. Okay, and then you get use catalyst actually. Okay, other stuff too. You use pressure, higher temperature. Use catalyst, vanadium oxide, chromium oxide. Okay, chromium trioxide. Okay, okay, some other stuff. Okay, so this thing is CH3. CH2, 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 CH3. So I mean, and hexane. Okay, this normal hexane alkane will turn into benzene. Okay, this is the formula. You should know how to write this thing, how to write the reaction. Okay, the second one is from sodium benzoate. This is kind of weird, a bit sodium sulfur carboxylic acid. Okay, so you get, this is an aromatic carboxylic acid, sodium benzoate. Okay, and this is sodium benzoate. Okay, and then you use sodium hydroxide. Of course, you heat the mixture. When you heat the mixture, what happens? This part, I'll show it to you. This part is going to form sodium carbonate. Okay, we have how many sodium atoms? 2 sodium atoms there, Na2, and then 1 carbon. And how many oxygen atoms? If you just count there, it's going to be 1, 2, 3. Okay, 3 oxygen atoms. So it's sodium carbonate. Okay, and then what left? You have this hydrogen. Just add to structure. It's going to be benzene. Okay, like this. benzene plus sodium carbonate. Of course, you should heat the mixture. Okay, you heat the mixture. It's common. Sometimes they add calcium oxide too, but like, forget this is, you should be able to write this reaction. It's common. And the next one is kind of important. Okay, they say you can actually combine 3 molecules of ethyl acetylene. Okay, this is C2H2. Okay, and then 3 molecules of C2H2. This is acetylene. Okay, where in a hot iron tube. Okay, it's going to be F red. Okay, so hot, okay, iron tube. Okay, if you use this thing and you apply some pressure and temperature, okay, higher temperature, okay, actually red hot iron tube is you need to heat it. Okay, sometimes they use copper too. Okay, pressure, temperature, you can write like 500 degrees Celsius there too. Okay, what do we get? We get C6H6. What is it? It's benzene. Okay, actually you can multiply 3 times 2, 3 carbon atoms. No, 2 carbon atoms, you multiply by 3 in each molecule you have, so it's going to be 6, and then 3 times 2 is going to be 6. Okay, but they say trimerization. Okay, trimerization of acetylene. Okay, 3 molecules coming together to make a polymer kind of structure, a larger one, a bigger molecule. Okay, so and there you have a question. They say if it is 33.6 liters, how many grams of benzene will form? Okay, mass of benzene, and you are going to do what, like stoichiometric questions. You should know how to calculate this stuff. Okay, 33.6 liters. Okay, is going to be you use n is equal to v divided by 22.4. Okay, so it's going to be 1.5 mole. Okay, and then you know the ratio. Ratio is what? 3 moles will give you 1 mole of benzene. So it's going to be 1.5 mole is going to be 0.5 mole benzene. Okay, so 0.5 mole, and you should use n is equal to mass divided by molecular weight. Molecular weight is 78. Okay, if you just, and this is the mole, 0.5, molecular weight is 78. If you just multiply, you get what? You get 39 grams of benzene. Okay, that's it. That's all I have for you today.